The first player that I want to go over is this guy right here, the ribosome. We're talking about making proteins. I taught you guys during our cell chapter that the ribosome is very much going to be responsible, the organelle responsible for making proteins. This is a simplified diagram of a ribosome. I do want you guys to notice that you have two different units for all simplicity purposes. We have two subunits. We have a small subunit, so it's going to be the base, as you can kind of see, the bottom of that ribosome, and we have a large subunit of that ribosome. A ribosome is composed of rRNA. So the ribosome itself is RNA. It's ribosomal RNA. It's going to be in charge of making proteins. So between the small and the large subunits of the ribosome is the binding site for mRNA, our product for transcription, that red ribbon that we discussed. That guy, once it leaves the nucleus, is going to find its way over here, and then it's going to find its way in a ribosome and then initiate the process of translation. We also have something called the tRNA binding sites. So we have something called a P site, it's kind of shallow area in the large subunit, and we have something called the A site. I want to point out what these sites are for. These are binding sites for something called tRNA. Now, as another RNA that I'm teaching you guys, tRNA, think of the T for transfer. Another way students think about this little t is for translation RNA. This means transfer RNA. tRNA is actually shown over here to the left. What tRNA does is it transfers amino acids to the ribosome. So here on the tRNA, it's going to have an attachment for an amino acid. Different amino acids will be here. It just depends what tRNA is carrying what amino acid. It'll be specific. On the tRNA as well, remember that amino acids are based on the codon, on the mRNA, what three nucleotides are reading on that codon to match that amino acid. Well, in order to see what the mRNA is reading, the tRNA has something called an anticodon. Notice it has 1, 2, 3 spots. These spots are also nucleotides that are going to complement the mRNA. So that way it matches to the mRNA and it brings over the accompanied amino acid that it wants to read for. So transfer tRNA then has RNA nucleotides that complements the mRNA, and it's going to bring over the amino acid. It's really the player that's involved in bringing over that amino acid to translate from nucleic acid language to protein language. Ribosome is going to be the spot where this transfer is completed. So again, the anticodon. The anticodon is located on the tRNA. It complements the mRNA in order to read for a specific amino acid. So let me show you guys this image now that shows you the three different players that are involved in translation. To point out the three players before I get into detail, there's my mRNA, messenger RNA, there's one player, tRNA, that's transfer RNA, there's the second player, and then envisioned in blue here in the back, my ribosome. That's my third player, my ribosome, protein machine making rRNA to also describe a ribosome. So let me explain this image, the players of translation. Here's my mRNA. There's the cap of the mRNA. It's going to be the start process of protein making. Envisioned in this light pink here is going to be my start codon. It's going to be methionine that starts all proteins. And it continues on in triplet form. 1, 2, 3 will bring an amino acid. 1, 2, 3, another amino acid, and so forth. I can actually see 1, 2, 3, there's another codon. Now here, the next one's 1, 2, 3. I can see that that codon, that's one codon, 1, 2, 3, attaches to an anticodon. Its complement on the tRNA that's going to match, bond, base pair roles. And the tRNA, I can see, is located in the P spot here. It has a growing polypeptide chain. Each amino acid, seen in these different shapes here, are going to be added growing the polypeptide. So this is kind of the elongation site where it's growing. The A site on the ribosome brings a new tRNA. That amino acid then gets bonded to the existing long chain. That's called a peptide bond, amino acid to amino acid. It gets added, and then a new tRNA will come in based on the next codon set, with this tRNA then leaving without that amino acid chain. It's going to leave this behind, and you'll see that in a video. So it's kind of like this: step 1, move over in line. Step 2, now you're done. Exit. And multiple tRNAs will be involved in this process as they're coming into the A site, leaving then, growing the polypeptide chain. Okay, written in text format, if you would like to see all that information that I just discussed.